Everyone, welcome to Python Pro by CTC. This is day 23 and we will be dwelling into the world of searching algorithms in Python. Searching is a fundamental operation in comparisons, and understanding how to efficiently find elements in a collection is key to writing effective programs. So why searching matters? Let's say you have a phone book and you are searching for a specific person's phone number. You wouldn't be starting from the beginning, right? You would like to jump to the specific section. For example, if you are searching for the name Rohan, you will be starting from the letter R to get the information quickly. That's essentially what searching algorithms do in the world of programming. So let's start with one of the simplest algorithms, linear search. It works by checking each element in a collection one by one until a match is found or the entire collection has been searched. For example, let's say here is an array and these are the list of elements here, and we are here to find the element 78. So we will be traversing from the beginning of the array till we get 78. We will be initiating a for loop and we will be going through elements one by one by one by one till we get the element 78. If there is no number 78, it will go through end of the array so that it will return element is not found. In action, we will be creating a function here called linear, where we will be passing two arguments, the array and the target element that is to be found. We will be using a basic for loop where we will be iterating till the end of the array we just passed. So if the ith element of array is target, we will be returning the index of the element found. Else, if we haven't got any element found, we will return -1 indicating element is not found. So let's create a list here. Now let's say the target is 8. We will have a new variable called search where we will be storing the results from the function. We will pass the list and the target here. So if the search is -1, we will know that the element is not found. Element not found. Else we will have a positive index, meaning the element is found at the returned index. So let's see the output. We should be getting 1 0 1 2 3 4 4 as the output here. Let's see. We have got 4 as the output. Let's change the target and let's see what happens. Let's have it as 2. 0 1 2 3 4 5 6 and 7, and the element is found at 7. It's working properly. What if I'm giving a number which is not in the array? Element not found. So this is how linear search works. But the problem with linear search is it is using a for loop and it will be going through every element one by one by one. So the time complexity of this algorithm is O of n. Let's explore binary search. Binary search is a more efficient algorithm. This algorithm is applicable when the collection is sorted, but linear search is applicable everywhere. It repeatedly divides the search space in half until the target is found. It has a time complexity of O of log n as it divides the search space by half for every iteration. This time complexity makes it much faster for large collections compared to linear search. Let's see how binary search actually works. So here you got the same array and the same target element. So we'll be having left pointer, right pointer at the mid pointer. Left pointer is the starting of the array and right pointer is at the ending of the array, and the mid pointer is actually the average between those two. So midpoint is equal to left plus right by 2. So 0 plus 10 by 2 is 5. So the mid is at the fifth element, fifth index. So we will be checking if mid is equal to the target element. No, 38 is not equal to 78. 38 is actually lesser than 78. So what we will be doing here, we will be shifting the left element to mid place. Why? We of course know, as this is a sorted array, that 38 is lesser than 78. So the 78 should be on the right side of 38. As you can see here, 78 is on the right side of 38. So we'll be moving the left pointer to mid pointer, and the mid dash again L plus R by 2. So what we have got here, 5 plus 10 by 2 is equal to 7. We will be rounding off decimal values. So here we have got 7.5, so it is 7 here. We will be again doing the same thing till we get the element 78. So as you can see, we got the same array, we got the same target element, but we still have really lesser number of iterations. For example, here we have got 1, 2, 3 and 4th iteration, but in linear search we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's more than 2 times of binary search. Now you can see why binary search got time complexity of O of log n. Let's see the code in action. We will create a function here and we will pass 2 arguments, array and the target. So we will initiate by the left pointer and the right pointer. Left pointer is 0 as it is at the starting of the array, and the right pointer is the last element of the array. We will create a while loop if left is lesser than or equal to right. So we wouldn't have any edge cases not covered. Now we will assign the mid. Mid is equal to left plus right floor division by 2 to get the value rounded off and not getting decimals. If array of mid equal to target, what we will do, we will just return mid. If array of mid lesser than target, what we will do, left equal to mid plus 1, and we will do the same thing. Else, if both the conditions are not satisfied, that is, if the target is lesser than the array of mid, right equal to mid minus 1. If the element is not found, we will just return minus 1. So like the last time, we will create an array 1, 5, let's say the target is 9, and we'll again have search binary of list comma target. If search is -1, meaning the element is not found, we will just print element not found. If it is found, we will have a index return, so we will just print the index element found at let's see what we will get. Element is found at 6. Let's see if it is at 6. 0, 1, 2, 3, 4, 5 and 6. Let's change it to something which is not in the array. Let's say it's 10. Let's see what we will get. We got element not found, as it should be.